Hi, it's me again. I have a couple of requests, actually more than a couple of requests to the people have prompted to install the motor, the DC motor to the little generator or the pump, whatever you want to call it, and to have a vibration, almost a free vibration out of it. So what I'm going to do is I'm going to do a slow breakdown to the material I use, how I attach the motor and all that. So I'm going to readjust the camera so we'll go to business, so you don't have to look at my ugly face. Alright, so the material I use is very simple. It's 3/4 inch plywood, laminated wood or plywood, roughly about 1 meter long, and probably about maybe, I don't know, 20 some centimeter wide, the widthness, and just enough so we have room to work and put the battery and stuff like that, and put a little light bulb so you can do some tests on it. But the motor, the motor, I just took some strip of the same plank. I just cut some strip out of it, so I had some material to raise the motor where it was supposed to be going. So I found out 2 pieces of 3/4 inch with the motor sit on it with a little bit of a foam insulation on it is perfect height. And to put a little cradle, I just put 2 small pieces of plywood and screw on the top there, so I can put my little motor, and it sits perfectly nice and tight, and put 2 straps all around. So it's very simple, nice and secure. This motor do not have any vibration when it runs, absolutely zero vibration. So now, and then what I did here is the calculation of the height of your pump to the bottom, so you have enough room, and you want to give yourself some room to put a little bit of insulation so it doesn't make a lot of noise, like vibration noise on the board, because you have to remember this is like a microphone, it amplified noise. So that's why, this whole thing is, I put a little bit of packing, it's called just packing foam, right? It's a 1/2 inch thick. You can cut whatever piece you got, put a piece on the bottom, and all you got to do after that is slide the piece here. Now I'm going to show you what gear to use. This is that little pinion gear I'm talking about. You can buy that in the hobby shop. Bring the pump with you so you get the right size holes in it. You might have to, this one here, I have to put another drill through it to increase the dimension of the center of the hole so you can slide over my shaft. But as you can tell, you will see here, it clearly shows it's got a loose set screw. Can you see a loose set screw there? Right here? Right? So you can secure that gear to the shaft so it won't come out. So that's all you gotta do is put a little gear like this, which is just over the size, the diameter, the inside of that plastic hose, that little plastic tubing, which you can buy. And if you go to a place where they sell fish tank and pets, you can buy that hose easily there. So that's all I do. I shove that over. Now I'm going to show you. It's very simple. Just play with the hose a little bit to loosen it up and warm it up with your finger, and just put that over and wiggle a little bit. See, the hose is already over the gear, and you just keep pushing it till you pass the gear a little bit, so it kind of cramp on the other side so it won't come out. It's very simple, and it will give you a flexible joint with no true connection from steel to steel, and some electrical can be bypassing that. So you're removing it by putting an air gap in between. Okay, so very simple again. So now all you have to do is take, now your plastic tube is shoved over, stick the whole unit and push it over the shaft of your motor. The shaft of the motor have to be slightly bigger than the tube, but it will happen anyway from the tube shrinking. The tube is not an accurate measurement anyway. So it will be tough to push it, but just keep pushing it till you reach a distance between the 2 shafts. That's mean the distance from there to here to there, about 1/2 inch. That's all as far as you want to do it. When you achieve that by pushing your pump, I'm going to put that pump back. See how simple to put the pump on? All you got to do is do that. The pump is in place. You don't have to tighten up this motor at this pump, because it doesn't have all the resistance goes away as it spins. So, but you want to stop going forward. So what I did, I just cut another piece, and just to secure my distance, I just put another piece of foam in the front so she cannot go forward. It's that simple. And I did another little piece like this underneath here in the front, so everything is sitting on something, so we don't have that noise or vibration. So that is about how easy it is to put this little thing together. Go to a hobby shop, get that little gear to fit in that shop. Take your pump with you. Say, I want a small gear will fit into a plastic tube. First thing, make sure you get the size of your motor shaft. Buy the plastic tube so it fits tightly. Not you have to really push into it, but just slide over tightly the shaft. Then you find yourself a pinion gear that fits on that shaft or fits in that tube, and then you can always open and close the hole of the loop pinion gear with a drill. You just drill through you. But this is how simple this thing can be put together in a few minutes. As you see, it took me seconds to put it back together and seconds to put it out. All you have to do when you want to take it out is just pull it out. Here we go, the motor is out again. See? A couple of seconds. You want to put the thing back together, you push it back, boom. There we go. It's reinstalled. So please, it's so simple. If you cannot understand that, turn the sound off and play this video really slow, because it's very simple. It explains everything. And the same thing, like now you get another, I mean, I put this little hose in 2-3 seconds on that little gear. When I started doing that, I thought about all kinds of different complicated joints and velocity joint and all that. And then I had to come to realize I was thinking way too much. A plastic tube or rubber hose will do the same thing. A nice little rubber hose with some cloth bread into it will fit over the shaft, over the gear, will give you the same thing. I chew the plastic so I can see between. I don't have any arcing. It gave me a window, and you will see there's no arcing in between when that thing runs and you're producing a lot of voltage on the other side. So there you go, folks. I hope that's going to very simplifies how to hook up those two little things together, and then you can just hook up your Lulu bulb and have fun. Look, oh, here's some technology I'm going to give you. I forgot. If you move the coil out of your magnet, it acts and you're not going to get shocked. You can hold that. Look, it's just like a rheostat. It's the perfect rheostat for working on try to find out energy and stuff like that, because we're not using any amperage. All we're doing here to do the rheostat is reducing the field of electron into the core. Interesting, isn't it? Well, I hope you guys are gonna have a good one, and that's the little video I'm gonna put in for you guys. Let me bring that up. So it's that simple, folks. It's no miracle. It's no Houdini. It's no special way to do it. Simple, logical move. And I just explained to some people logical meaning of the word. Logically explain it. It gives you the way to do things. So there you go. I hope you will enjoy it, and you will be able to put those things at less than 15 minutes. Okay, that's just an explanation of those two batteries. We're looking at two 18-volt battery that connect in series. So minus, plus, I jump to the other battery to minus, back to the other pole at plus, into a switch. It's just an on-off switch. Goes to the motor, 24-volt motor, DC, brush fed. And here is that little pump with a little generator, which is a washing machine pump from front loader machine, and it's just hooked up with a little piece of plastic tube in between. The pump is not tied up, it's just sit there in the front. The motor is secure with the strap and the screw. And then we move on, and then it's got two legs output, and that's why I hook up the wires to the lights, and then the lights will work when you turn it on. Now what I'm going to just go through here is, here's my step-up transformer I use from a ozone machine. Now I'm going to try to get as close as possible with the camera so you see the number on it and how it really look. So as you can tell, is no secret. It's just a normal step-up transformer. The two legs goes out. This is, I use this burn up fluorescent tube as a sensor for when I'm producing radiation over those bulbs. This tube will light up just sitting on the top of the wire. And we go farther up, and here we have, which I call it a spark gap, which I will be using that later on when I start running the whole unit together. Now I also have another loop pump, which I cut the plastic out so people can actually see how it works. And I'm going to be pulling the magnet, as you can see. Now you see me pulling that little magnet. That's the one we spin inside this. Right? So it's not that complicated. It's just a 2-pole magnet. And we'll put that back in here and see it sucks itself because of the magnetic field. Now this is the coil and how it looks like when the plastic is all removed from the top. Nothing fancy, pretty simple, and there it is. This is, we call that a pump, a generator, oscillator. You can put all the name on it. I don't, all I know, it's pushing up a lot of power when you hook it up properly in series and put a loop into it. So I'm gonna stop that and go and install this camera back where it belongs on a tripod so I can start a little bit experiment.